So today we're looking at section 4.3. We're trying to prove that two lines are parallel. So we're going to be on page 185 as we get started. So we start by writing converses of the parallel line theorems that we talked about yesterday. So you form the converse of an if-then statement, if P then Q, by swapping P and Q. So remember, this is what's called a conditional statement with a hypothesis P and conclusion Q. So you form the converse by switching your hypothesis and the conclusion. So the converses of the postulate and theorems you've learned about lines cut by a transversal are true statements. We're going to specifically write these, but I just want to, again, state that we're starting with conditional statements. So conditional statement says if P, then Q, if hypothesis, then conclusion. So the converse, we switch the hypothesis and the conclusion. So it'd say if Q, then P. If you wanted to see this as a real example, I can make the statement, if an angle measures 90 degrees, then it is a right angle. So this is my conditional statement. So the converse, I'm going to switch the hypothesis and the conclusion. So the converse would say, if an angle is a right angle, then it measures 90 degrees. So this would be a more concrete example of a statement and its converse. So the diagram shows two lines cut by a transversal T. We want to use a diagram and some statements here to complete steps A through D. So they say they're given statements, but they didn't actually tell us all of it. So we're going to fill it in ourselves. Lines L and M are parallel. Angle 4, we're going to say, is congruent to angle 6. We know that because they are alternate interior angles, and we know that those are congruent. We're going to say that angle 6 and angle 3 are supplementary. Those are our same side interior angles. And then angle 3 is congruent to angle 7. That's because they are corresponding angles. So we're going to use two of the given statements together to complete a statement about the diagram using the same side interior angles postulate. So by that same side interior angles postulate, the first thing we had to know was that the lines were parallel. So we're going to use the statement lines L and M are parallel. I'm going to go ahead and shorten it to say L parallel to M. So if L parallel to M, then we see what are our same side interior angles. Well, angle 3 and angle 6. So we'd say angle 6 and angle 3 are supplementary. So if we take the converse of that, we're going to switch the order. So instead, we're going to say if angle 6 and angle 3 are supplementary, then line L is parallel to line M. We're going to do the same thing here. So this time we're using the alternate interior angles theorem. So again, it's all based on if line L is parallel to M, then in this case angle 4 is congruent to angle 6 because those are the alternate interior angles. So converse, we have switched up. If angle 4 is congruent to angle 6, then line L is parallel to line M. And then using the corresponding angles theorem, say if line L is parallel to line M, then angle 3 is congruent to angle 7. And by the converse then, we switch it. If angle 3 is congruent to angle 7, then line L will be parallel to line M. So in general, how do we form the converse of a statement? We switch the hypothesis and the conclusion. So normally it's if P, then Q. The converse says if Q, then P. So what kind of angles are angle 4 and angle 6? We said they were alternate interior. And then what does the converse we wrote mean? Well, it means if we see two alternate interior angles and they're congruent. If we see two alternate interior angles and they are congruent, then the lines are parallel. So we basically said them already, but these are the converses of the theorems we talked about yesterday. So the key here is that yesterday when we did these, we said before we knew if two lines are parallel, then this relationship happens. Today, what we're saying is if this relationship happens, then the lines are parallel. So we're essentially looking at the same things. We still want same side interior angles to be supplementary. We still want alternate interior angles to be congruent. We still want the corresponding angles to be congruent. But now we're saying as long as they are having these relationships, then the lines will be parallel. So let's check out an example. Mosaic designer is using a quadrilateral shaped colored tiles to make an ornamental design. Each tile is congruent to the one shown here. So if we look and see, we've got angle 1 here is 120 degrees because it's in the top left corner of the tile. Angle 2 is 60 degrees because it's in the bottom left corner of the tile. So the relationship between the two angles, they're supplementary. So because they are supplementary, and then because they have the same side interior angle relationship, we can then say that the lines are parallel by the converse of the same side interior angles postulate. So now we're looking at this situation. So we still have the same basic, we still have the same basic shape size. Sorry about that. And relationship. So the angles are still 120, 60, 60, and 120. So this time we're looking at angle 1 is in the bottom right corner. So that means it's 120 degrees. Angle 2 is in the bottom right corner of its quadrilateral shape, so it will also be 120 degrees. So the relationship is that they're congruent. If we check out their naming relationship, where they're located, they appear to be corresponding. So our conclusion then, since they are congruent and they are in those corresponding locations, then we could say that L1 is parallel to L2 by the converse of the corresponding angles theorem. And we can shorthand a little bit because it's a lot to write. So what if? Suppose the designer had been working with this basic shape instead. Do you think the conclusions would be different? Well, no, they're not going to be different because they have the same general pattern to the numbers. Same general pattern to the angle numbers. So let's try a couple more. So if we look here, angle 1 is in the top left corner. That means it's going to be 120 degrees. Angle 2 is in the bottom right corner. So it will also be 120 degrees. Now if we notice the naming statement, these would be what we call alternate interior angles, which are supposed to be congruent, and they are. So that means line L1 parallel to line 2 by the converse of alternate interior angles theorem. And then number 5. Number 1 is in the top right, so that means it's going to be 60 degrees. Angle 2 is in the bottom right, so that makes it 120 degrees. Well, those happen to be supplementary. They add to 180. And our naming would say that they are same side interior. So because they are same side interior and because they are supplementary, that means the lines have to be parallel. L1 parallel to line 2 by the same side interior angles, and this one is a postulate.